Hi guys, welcome back to the channel. I hope you all are doing good. So, okay, we are going to continue with the DSA sheet. Many of you got scared. Where did you run away? No, I'm here only. I will be doing the problems. And yeah, so today's video, we will do an interesting problem and we'll finish off DP as soon as possible. Okay, so today's video is largest rectangular submatrix whose sum is 0. See, before trying to solve this problem, you go to my channel and go to my playlist, that is dynamic programming, DSA sheet topic dynamic programming, and then you watch this video. I'll just minimize myself. See, this video is there, maximum sum rectangle. So if you first watch this video, then you know Cadane algorithm. Okay, you should also be knowing this one, how to find length of largest subarray with sum 0. So before solving this problem, it is better to have some prerequisite knowledge. Otherwise, this problem will look like a very, very new problem. Although in the video further, I will explain why am I telling you to have this prerequisite knowledge. Just first watch this if you haven't. But if you have, we can continue further. So what is the problem? We are given a 2D matrix and we have to find the largest rectangular submatrix with a sum equal to 0. Okay, so this is given as input over here. We will take a smaller matrix to first of all identify. So suppose our matrix is something like this. Okay, so suppose this is our matrix. In this matrix, we have to tell the largest rectangular submatrix with sum 0. So if you carefully analyze and observe, you will get to know that this matrix here, I'll write this here now, 1, 2, 3, -3, -2, -1. Yeah. So this submatrix, see, if you find the sum of all elements here, what does it mean? Sum of submatrix, find sum of all elements. So this is 6, this is -6. So 6 plus -6, 0. Correct. Fine. So the sum is 0. And you can clearly check that this will be the largest one. What is the area? Area of this will be what? Length into breadth. Length is 3, breadth is 2. So it is going to be 6. Fine. So like this, see, this question, they have asked us to print the matrix. So this is a little challenging, right? I mean, not so challenging also, but yeah, we have to print the matrix. So how can we print the matrix? We need to know where does the matrix start? Where does the submatrix or where does our answer start? So we need to know starting row. We need to know the ending row, as well as we need to know the starting column and ending column. So if we know these these 4 things, then we can print our submatrix. Starting row, starting column, ending column. 4 things are there. So these things we have to know. And also we should find the one which has largest area, because largest submatrix means largest area rectangle only. Fine. So here we will be using Cadane algorithm. How we will use Cadane algorithm? The reason why I told you to watch this video, maximum sum rectangle, is because we have discussed the approach there, the Cadane algorithm approach. What is that approach? See, how we will be solving the problem is, see, this is a 2D matrix. We want to convert it to 1D array. Why we want to convert to 1D array? We can apply Cadane algorithm there. We can apply something like a Cadane algorithm. But in this case, instead of Cadane algorithm, we would have to know this algorithm. That is how to find length of largest subarray with sum 0. See, we have done many problems where we have done count subarrays with this sum. So there will be a target sum, right? There will be a target sum and we have to find a count of subarrays with this sum. So we have used a hashing, that is map concept, where we use the prefix sum and map to check if that prefix sum again occurs or not. All those things we have discussed, right? We have done many problems. So that is why you read this article also, how to find length of largest subarray with sum 0. What our approach is going to be, this matrix that is given to us, we want to convert this into a 1D array and then apply this one. Find length of largest subarray with some 0. Okay, so this article I'll put in description. You read it. So we want to what does it mean convert to 1D array? It means, for example, if we are traversing the matrix row wise. So first row, these are the elements. This itself is a submatrix, correct? This itself is a submatrix, 1, 2, 3 this is a submatrix. Now, if I have to go to second row, it will be -3, -2, -1. And this is a submatrix. Instead of writing like this, what I will do, 1, 2, 3 is there, na? This row, all these elements, I will add it with the corresponding column element, column wise. So 1 plus -3, 2 plus -2, 3 plus -1. So what is that going to be? 1 plus -3 -2, this 0 and this 2. So this is going to be my transformed 1D array. So this 1D array, what is it actually representing? See, this 1D array -2, 0, 2, it is representing this submatrix actually. I have just converted it by taking the summation. So now if I find out what is the length of the largest subarray having some 0, if I get the answer as suppose 3 here, it means that in this submatrix I have found the length. I have found the length. See, over here, length of largest subarray with some 0 is 3. You can clearly see now entire subarray, entire array only is having a 0, some 0. So length of largest subarray with some 0 is 3. It means that in this submatrix, length of the largest subarray with some 0 is 3. So we have got length. We need breadth. How we'll get breadth? See, the starting row is I, ending row is j. So breadth is going to be j minus I plus 1. And length we have. So what is area? Length into breadth. So see, one problem is already solved. One part of the problem, length into breadth, that is done. That is why I told watch this video, maximum sum rectangle. We are converting every submatrix to a 1D array. So we can get length and breadth. I have shown you how to get length and breadth. I will take some more examples. See, what I'm trying to say is, some of you might not have understood yet. So I will take more examples. What we will do, we are traversing the array. How? Row wise. We are traversing the array row wise. First we will get this row. Then we go to next row. Instead of making this a 2D matrix, we will add each and every element to the corresponding column of our 1D array. We'll make only 1D array and we'll add it. So it becomes -2, 0, 2. So in this iteration, we will get this array. In the next iteration, what array we will get? In the next iteration, see, -2 plus 1, 0 plus 7. So it is going to be what? -1, 7, and 5 plus 2 is 7 again. So what does this represent now? -2, 7, 7. Sorry, -1, 7, 7. This 1D array corresponds to the entire 2D array. This entire 2D array, it corresponds to that. Like this, starting at every row I have to do. See, now I started at which row? At row 0. And I went on until last row. Now I will start from row 1. So initially my starting was this array. Now if I start from row 1, my starting array will be this, and I will build each and every array like how I told, add the corresponding column elements and make 1D array. So I'll start at each and every row and I'll make only 1D array, and I'll find the length of the largest subarray with some 0. How to find that? First read this article. I have discussed this many times in the previous videos also. I think even in this video I have discussed with Cadena algorithm. I guess I have, or maybe in the some other video, I'm not so sure, but I have discussed that. that map and frequency concept, prefix sum concept. Okay, so if you can observe here, this array, what we'll get? Minus 2, 0, 2. What is the sum? Total sum only is 0. So length of largest subarray will be 3. And if we find out the breadth, we'll get the area. But now we have to do what? We have to print the matrix also. Suppose we have to print the matrix. Okay. Now what will happen? We will have only 1D array like this. We will find out, okay, this is having max length 3, max length 3, max length of subarray having some 0. This is the highest. So for that, we will find out where does it end? What is the ending index of the subarray? I want to know ending index of a subarray. This subarray ending index is going to be 2, because entire array itself is having some 0. So tell me one thing, if I know ending index and max length, can I find out starting index? Of course. How can I find starting index? It is going to be ending index minus max length plus 1. See, there is a starting point, there is an ending point. The total is length. If you know end point and length, can you find starting point? Of course. What will it be? Ending point minus length plus 1. Why plus 1? Because it is 0 based index, as well as if there is a subarray like this. Okay, this plus 1 is saying that from this point to this point we have the same subarray sum, which means that from the point which is one ahead of our initial point, from there the entire sum will be 0. That is what it means. I'll explain this again. For example, see, if I take 4, 0, minus 4, if I take this over here, in my map I will store sum equal to index, which is 0. So map of 4 will be stored with 0. Here it will come and I will see, okay, what is the prefix sum till here? So till here prefix sum was 4, here also 4. Fine. Now I am getting to know that 4 is in the map. But where is the actual subarray starting? Where is the actual subarray with the sum 0 starting? With total sum 0, where is it starting? Not from here, from one index ahead. That is why starting point will be ending index minus max length plus 1, because that is the starting point of my maximum length subarray. So first you read this article as well as you solve this problem, then this problem will be piece of cake. It will actually be piece of cake. So in this another example also, if you see here it is given that this is the matrix. It is already highlighted, right? So here what will we get? Our max length as 2. And breadth will be j minus I plus 1. So where is it ending? Where is the matrix ending? In which row? Third row, starting in first row. Length will be 3 minus 1 plus 1, which is 3. Sorry, breadth will be 3 minus 1 plus 1. So area we will get. It is very easy to find out starting row and ending row. Starting column, ending column. For starting column, ending column, what you have to do? Just pause the video and think. Starting column, ending column is this only, na? Ending index is same as ending column. Index is not changing, because whenever we take a 1D array is having same number of columns. Our 1D array will have same number of columns. So ending index is the same as ending column, and starting index of the subarray is same as starting column of our answer matrix. So time complexity over here, I guess it is going to be nmm. O of nmm, I guess. You can do the other way also, nm, whatever. So totally, I guess it will be n cube complexity. Okay, so first solve those two problems, this one plus this one, solve those two. Now I'll show the code because coding this will take long time. I'll show the code quickly. See, first is input r comma c, okay, rows and columns. And now I have made some variables, starting row, ending row, starting column. What is this ending column? This is going to be for finding my answer submatrix because I have to print the submatrix. See, here they are printed. They are printed. The output is the printed one, right? They have printed it. So for that, I need to know starting row, ending row, starting column, ending column. Fine. Then I will make a matrix and I will take the input of whatever is given. Input, fine. Okay. Now I have made a variable called final length, which will be the length of my final matrix. That length is there, that will be my final length. Now what I'm doing, for every iteration, for every row, I have to build the answer. That means, see, take this matrix, okay? This matrix, what I'm doing, 1, 2, 3 is one array, is one submatrix, you can say. Then like this, another submatrix. Then like this, another submatrix. Okay, so this was from first row starting. Now start from second row. -3, -2, -1. This is one submatrix. Then -3, -2, -1, 175. This is another submatrix. Some of you might question, hey, but why are you not taking submatrix like this? Why you're not taking this? So this will be already covered. If you find out a subarray having a length 2 only, if a subarray has length 2 and you know where it is ending and starting, then you will easily find out that this is only going to be the answer. So here we will take 1D array with a length equal to number of columns, but the answer can be anywhere in between. So don't worry about that. Don't get confused that why are we taking all the matrices of fixed number of columns. We will take that to maintain one 1D array. But our answer can be anywhere because our subarray can be anywhere, right? Just if you're getting confused with submatrix, transform it to subarray. Now subarray can be anywhere. And submatrix will be what? It only depends on number of, it only depends on the breadth. See how many rows are there. It depends only on that. It only depends on that, right? So that's why I said first solve this problem. Everything will be cleared. So that is what I am doing here. See, for every row, from that row I will go building, and I will take a array, current array, which will be my 1D array. That is what I was telling na. For every 1D array, I will do this only. I will send it to a function called subsum, subarray sum. Okay, and why is it returning a pair? It is basically returning maximum length of subarray as well as at which index it is ending. See, ending index is important here because ending index is going to be my ending column, because my 1D array and matrix, the number of columns in matrix, that number, that C over here, this C is same as length of my 1D array. I'm converting it to 1D array, right? That length of the array is same as number of columns. So my ending index of subarray will be ending column of my submatrix. If I know ending index, I can find out starting index easily. So this entire function that I have written here is the same as this code. I'm basically finding what is the length of my maximum subarray with some 0, as well as where it is ending. What is the ending index? That is all I am finding here. Fine. And once I find that, I'm making a pair. I have to return it as a pair. I have decided I'll return it as a pair. So pair is what? Max length and ending index. So this entire code is to find out what is the length of the maximum subarray with some 0, as well as where does it end. And I'm returning that pair. Fine. Where am I returning? It goes here. Now I'll check if my final length is less than p dot first. What is p dot first? It will give me max length of the subarray for that iteration. For that particular iteration, it will give me the maximum length subarray. If my final length is less than that, okay, I'll make my final length equal to that. And then I will change my starting row, ending row, starting column, ending column. Starting row will be I, ending row will be j. See, j is the inner loop here. J is going to start from I and it will end at R, the number of rows, right? So starting row, ending row, I will find out. Starting column, ending column, I will find. How to find starting column? Starting column is, as I told you, ending index minus max length plus 1. Here, don't get confused. Ending index is same as ending column. Because I'm again repeating this, number of columns in the matrix is the size of our 1D array. This current array, C, the size is equal to C, number of columns. So starting column will be, what is ending index? P dot second. In the pair, second is the ending index, right? So P dot second minus P dot first. Ending index minus max length plus 1 is starting column. Ending column is ending index only. You need these 4 to print the array. If you just have to find out the area, nothing, this is not required. Just this final length is required. And of course you need, not only final length, you need these 3. So if you want to find out area, you need final length, starting row, ending row. Why you need starting row, ending row? Because you want to find breadth. Because area is length into breadth. So if you want to just find the area of the largest submatrix with some 0, this much is needed. If you want to print it, you need this much. Fine. Then I'll just run and show now. Here I am just printing all those things. What is my final array area? What is my starting index, ending index, all that. So if you see carefully here, I have taken which input? I have taken this, the thing that is given in GFG. This matrix I have taken as input here. Fine. And what is being printed? First, 6 is being printed. Why 6? If you observe here, what is the area of the largest rectangle? 6. Okay, so 6 is being printed first line. What is this? 1, 3, 1, 2. Starting row, ending row, starting column, ending column. See here. Where is the answer starting? Which? What is the starting row? 1. Row 1 it is starting. Where is it ending? Row 3. Starting column 1, ending column 2. Fine. And what is my answer matrix? Print that. So it is being printed. See. Simple solution. Convert it to 1D array. Find the length of the maximum subarray with sum equal to 0. You have to just put a thought how to get starting row, ending row, starting index, ending index. That's all. Only this you have to put a thought. Otherwise, it is easy. If you have solved this problem, maximum sum rectangle, then you will understand. So basically, this entire problem was converting 2D array to 1D array and applying the algorithm to find maximum length of maximum subarray with sum 0. Length of maximum maximum length of subarray with sum 0. That's all. That's all this problem is. Okay, so I'll put the solution. There was no place to submit. This question is not there. I don't know where it is. I will put as, but don't worry, I'll put the solution in the description. So see, I did not explain this code in depth because I feel you already know this. I have explained in many other videos, but I will definitely share this article, and this is very easy. It is very easy. I have used some idea of this in this video, so that's why I watched this video. So that's all for this video. If you really like it, hit the like button. Please share it with your friends as much as possible, and subscribe to the channel. It will really motivate me. And until the next videos, take care, stay safe, keep learning, keep growing, stay tuned. Bye.